So let me show you how to run uh, chirplet omega scan in Atlas. For that I'll have to SSH into Atlas. So I SSH into Atlas, then I have already set up a folder. I'll go there. So I'm going to that folder. Okay, so this is the folder we are in Atlas, in this folder, test folder. And to run omega scan, we need something called a configuration file. You can see it here. This is the configuration file, configuration.txt. So let's see what's there inside. So here, and this is a typical structure of a configuration file, you have to specify a channel name. So this is the channel of the background noise, so it's called h1 strain. Then we have to say something called frame type. It's the name that is attached to the name of the frame, and it's named as here h1 ninja noise. Then we have to give the name of the injection we are giving. So here the injection is also named h1 strain. Then also we have to give a type of injection. So it says IMR phenom 0 version 5A. So I specify here the injection factor to be 1. We can multiply the injection, we can make it 10, 20, whatever we feel like, but for the timing we stick to 1. Then there is something called sampling frequency. This is the frequency at which this scan is going to get sampled. Then there is something called search frequency. In this frequency range, the omega pipeline, the chirpletized omega pipeline is going to search. Similarly, for I don't know much about the time range. I don't know much about this. Then there is something called Q range, and Q is the frequency divided by the bandwidth, and we choose that to be 8 to 32. And then also we give a chirp range. The chirp range I just chose from 0 to 2048, and some other thing we will know later. And also we have to put this always plotting flag to be 1 to make sure that it plots the result. Okay, so then also we need to tell where the injections and the background noise, where it is situated. So that's stored in this file framecast.txt. Let's say how I'll show you how to create this. To create this I'll first run this command. So this is the folder where the injections are. So I run something called create framecast. It's a Perl script, so let me run that. It's creating the framecast. Just because I gave a name, so you have to give the name of the program, then the text file, and where the folder where the injection files are. So let's see if it's created. It has created it. See here, it has created framecast.injection.txt. After that, let me do the same thing for noise. I'll do the same thing for noise. I'll run this thing, and I have stored the noise information in another framecast file called framecast noise.txt, and I have put them together. Let me combine them both in one file. So I did this. So when so in this framecast.txt, let me open it. You will see these are all the injections. It tells me where the injection are stored, and when I scroll down, let me scroll down, it will tell me where the noise is stored. Okay, so now I'm good to run omega scan. Let's say I want to run omega scan for a particular time. This is the GPS time. So the command is I say omega pipeline scan, then the time, then C, the configuration file, and F the framecast text file, and R this command R stands for that it should plot. I'm telling it to plot. So let me copy this command and try to run it. Let's see if it's running. See, it's starting to run. It starts some X buffer. Then we're running a compiled Omega, so we don't need MATLAB. It's already compiled. So it says it's processing the channel H1 strain. You saw and it says it's creating the scan directory. If it creates a directory scan and puts all the information there. Let's wait. It takes time to process. It creates a text file, an XML file, and it creates an HTML summary. Let's wait. So it says now it's done. The scan is done. Let's ls. Now you see there is a new scan folder. Let me cd into the scan folder. So in the scan folder there is this time, that there is a timestamp, the GPS timestamp. So let me go into that. So you can see it has created a bunch of different figures. So let's see, let's go to this page. So I want to go to this page. So I copy this, then I will find that. So here, let me go to this page. Just wait for a moment till it loads up. Okay, so this page is now being created. So this is the page we just now created. So it gives a bunch of different things. So you can see three different things. So now it's just showing a spectrogram, a raw spectrogram, but we can whiten it. Just wait for a moment. It's a JavaScript. Oh, nothing happened. Let's see. Let me do auto scale. Oh, okay. So in auto scale mode, when I scale it, it scales the time, and you can see the scan. So there is an image signal in spiral module ring down signal here. So this is y-axis is frequency, the x-axis is time, the y-axis is frequency, x-axis is time, and it's increasing. The frequency is increasing with time. So it starts from here. It starts with an in spiral, and this is the merger part, and it's suddenly the frequency starts increasing. We can also see the time series. Let me see the time series, white time series. You can see this is the time series of the signal. This is the in spiral part, this is the merger part, and the ring down happens here. Yeah, so this is the basic how to run Omega scan, chirpletized Omega scan.